So this presentation is about how we do modern application development on AWS. Okay. There are tons of ways to do things on the same job, same task you want to achieve, as you guys already know. There are various ways to do it on AWS. And sometimes you get confused, what is the right way? And a lot of the time, the answer is not what is the right way, because there are multiple right ways to do a job on AWS. It's just what fits your unique business and team needs best. That is one of the challenges of using cloud these days. And that is why you need cloud expertise, specialized cloud expertise, to be able to make these decisions, which can save a lot down the road, a lot of effort, a lot of costs, and various other things. So with that in mind, since there are so many ways to do things on AWS, what I try to do in this presentation is basically bring all of those together and talk at an overview level. Like, we could not do a deep dive into a single approach, right? And then maybe in future presentations, we could do a deep dive into a specific technology. Okay. So let's establish some objective first. When we talk about modern development, right? So what is modern application development and how it is done, right? I think the best way to do this is if we establish some objectives. Development has been very time-consuming task inherently. It still is, right? If you are to do DevOps, and if you are to do development is more time consuming. It still takes more effort, more time consuming, because you are creating stuff. But now with everything we have, all the modern cloud technologies, the infrastructure choice that we have, we are able to get things done faster. Also, what helps us move fast now are the modern programming languages, right? When things used to be done in C and C++, they used to take much longer. Same goes for Java. But now you have Python, and you have Go, and you have JavaScript. It's just much faster to get things done. And now recently you have AI, you have Copilot and all other technologies that help us write code, GPT, ChatGPT, and all these technologies. So that is why it is very legitimate to expect that from a modern developer, from a modern development team, we should be able to roll out code fast. At the same time, when we release things to production, they need to be secure. And they should be following best practices. It should be of the highest quality, and we should also be using other modern cloud infrastructure best practices like high availability, scalability, while minimizing cost, right? So basically, here now in this era, we are expecting a lot from modern development. On paper, it does seem like we are expecting a lot, but actually in reality, it is possible. Because if modern best practices are followed, we can achieve it. We have achieved it in our teams, and good teams who follow modern best practices to achieve this level of speed and innovation and agility. Okay, so these are our objectives as a modern application development team. Next, I want to once again stay at an overview level, but talk about what are the main models when we talk about development these days. You hear a lot about serverless. So serverless is one. The other deployment model is containerized. And then there's an event-driven architecture that we could use depending on our use case. So notice I didn't mention server-based, because now in this era, there is no justification to use server-based. it's not a strong statement because every use case is different. So there might be valid use case where we would be using server-based deployment, but as a general rule, you don't need to do server-based deployment anymore because you have containers, okay, which is the better way to deploy applications. So can anyone tell, by the way, I feel free to make it make this an interactive presentation. If you have any questions, comments, feel free to interrupt, okay? So can anyone explain what serverless means?
Serverless means that the routes are defined in the main server that is deployed in like Amazon cloud. So in conventional way, we are making our server in our code, just like in Node.js, we are using Express.js. So this basically I know
about. Okay. Anyone else? Okay. So
yeah.
Go ahead.
Okay, so serverless means there is no server, which means there is no continuous compute resource running when there are no user requests, right? So
Close.
Okay.
Serverless, yes. Second part was correct. Serverless doesn't mean there are no servers. Serverless means that there are servers, but they are not yours. You are running your code on someone else's servers. And they are responsible for managing those servers. All the operational responsibilities, all the operational overhead, they are taking that for you. And all you care about is when the request comes in, my code runs on some server. I don't care which server it is, but it just runs on some server which is secure. So that is what serverless means. Serverless doesn't mean no servers. The servers are there, but they are not yours. You don't need to manage. So you cut the operational overhead with serverless. Now, containerized, I've listed and I've said they are an evolution of server-based, but then you also see the third point, which is Fargate. Now, Fargate is serverless containers on serverless. So there's an overlap. This is common with AWS and other public cloud providers, right? There is an overlap, things merge.
I have one more question on the previous slide. Okay, so for the first point, the serverless, and the third one, event-driven. So how can we differentiate them as separate models? Because even what I can perceive this is as that event-driven is can be an automation of a serverless model. My perception could be wrong.
Event-driven, once again, there is some overlap here, right? And it's, I understand if there is some confusion. It's not like 100% clarity. But just because of how things are structured and how many options we have, right? So event-driven is a paradigm, and where with event-driven, the idea is that you write decoupled application, right? So there is a producer of event and there are subscribers of events. The producer doesn't know who the subscribers are, and then the subscribers don't know who the producers are. And all the subscribers know is, okay, I need to subscribe to this event, and this is my event bus that I need to subscribe to, an event bus is going to do the routing. So that is event-driven architecture. Now, within event-driven, it could be serverless or it could be server-based, right? But within, when you talk about AWS and you talk about EventBridge, it's serverless. So it's event-driven and it's serverless.
Okay.
Similarly, you have PubSub architecture, which also comes under the same category, which is loosely coupled application, right? Now with PubSub, you could have a Kafka cluster of yourself, right? And still have basically loosely coupled event-driven PubSub or PubSub applications. But Kafka would be running on servers, which you might be managing, right? So these are two different things, but within AWS, if you talk about EventBridge, it's serverless and it's event-driven architecture. Okay.
Right.
Now we're going to go into some architectural pattern discussions. Initially, the audience for this presentation was different, but since when I found out that it will be within our team and we're going to have top-notch developers in this presentation, so I added more architectural related content to it, right? So first thing is, when you talk about serverless, within serverless, you could build a web application, you could build a backend job that process application, you could build a streaming application, you could build a serverless file processing application, right? So that's how I tried to structure this. So first, let's talk about web applications. Now, once again, there are other ways to build a web application, to build a serverless web application, but here I'm just talking about like a typical architecture, which we would use when building web applications, the serverless web application on AWS. We're going to have the static part of the application on S3. Static part includes if you have like a JavaScript-based web application, if you're using React or Angular or all these frameworks, the JavaScript code for the application would live in S3. That's a static part. Similarly, all the assets, media, all of these would live in S3. Okay. You would also actually, it's not depicted in this diagram, but you would also have a CloudFront distribution in front of S3 for efficient distribution of the static assets and caching. The dynamic part of the application, the business logic, would live in Lambda, which is AWS Serverless Compute Service, as you all know. And then you're going to have a REST API deployed on on API gateway. And the API gateway, REST API, is going to integrate with Lambda. And then for database, typical database technology to use for serverless is DynamoDB. You could use any NoSQL or any SQL-based database, but you have to make sure that the SQL-based database that you use supports serverless behavior. If you just use an RDS MySQL, it won't support serverless behavior or serverless access pattern. So you would need to use an RDS proxy. So not going into too many details there, but you have to make sure that your database technology supports serverless patterns. If you want to use SQL based, you could use Aurora Serverless. That goes well with the serverless architecture.
Just a little more detail I want to know about these serverless behavior.
Go ahead.
Yeah. So what I mean, I want to know that what kind of serverless behavior is for a DB. I mean, why DynamoDB behaves as a serverless DB, but the standard MySQL doesn't.
So it's a long discussion, right? I'm going to try to sum it. First thing is, obviously, DynamoDB being a NoSQL database, it's much faster compared to a SQL-based database. It's inherently faster.
Okay.
Plus, it has the ability to horizontally scale, which a SQL-based database, traditionally, they don't have the ability.
Correct.
So serverless, on the front, your compute is able to scale horizontally. But if your database is not able to scale horizontally, you're going to run into scaling issues. That's one fundamental problem in using like a SQL-based database with serverless, right? You could have the same problem with your server-based application, right? If you have like a fleet of EC2 instances deployed through auto-scaling group, your application tier, or your web tier is able to auto-scale, but your database is not auto-scaling. So you run into the same problem. If you have auto-scaling on the application and web tier, but you don't have anything on the database tier, you run into the same problem. So how do you auto-scale a traditional MySQL or PostgreSQL instance? Yes, you can add read replicas, right? But they are read only. So maybe you can auto-scale for the read traffic, but what about the write traffic? All the write traffic goes through the same instance, which is the master. So these are the challenges. Once again, not going into too many details, like what would be the solution for this, right? But these are the challenges that we face when designing systems. But if you use Aurora serverless, it will scale. You can horizontally scale it. And that is something that you can use with the serverless model. Aurora serverless gives you the horizontal scalability option, and it also gives you SQL. The world loves SQL, right? I mean, we have already established this. Even when I was studying, in our database courses, they taught us about other kind of database technologies and how they can possibly replace SQL. So like 30 years ago, people were trying to replace SQL or relational databases, right? No, they're still there. They're still there and kicking and going strong. So now I think we should just embrace that SQL databases are here to stay. That is why you have technologies like Aurora serverless and other SQL traditional relational databases that supports SQL, that support relational design, but they can scale horizontally. Aurora serverless is one example. There are other examples as well. There are other companies that have built these solutions which support horizontal scaling. Another problem which you're going to have if you use a standard relational database is serverless applications create a lot of connections. So when there would be a spike, you're going to have a lot of connections get created on your database, and it will run out of connection limit or run out of resources. So that is why I mentioned use an RDS proxy, because with RDS proxy, you could you have connection pooling, and you can it helps support the serverless architecture with SQL-based databases. All right. Any other questions here?
Yeah, one question relevant to Amazon API gateway. So on this gateway, we just have the routing table. Like as you said, that AWS Lambda.
Yeah.
We have all the compute.
Right. Yeah. Routing table is not the right term to use. You define your routes. You define your REST API on the Amazon API gate. And then from the REST API, you have integrations. On the integration, you can specify Lambda, you can specify an HTTP endpoint, and there are a few more that you can specify. So that's how it works. Say, okay, this path, whatever this path is, right? When request comes in to this path, you invoke this Lambda to process it.
Hey, I have a question as well on that. It's that when we need to go for a serverless model and the Lambda thing to serve the request, and when we should go for a traditional backend application servers approach. So can you set some rules?
Yeah. So this is it's a question which is difficult to answer, right? Because there's no right or wrong answer. Both approaches are good. Go ahead.
I think it's when we are talking about Amazon API gateway, we are not just talking about the routings like in our application. Like if we take the Django REST framework, we have our routings that this endpoint is called, and we are routing to here. We are routing to the Lambda functions. There we have defined function in our application. So we are routing to those. But this API gateway is not just a routing table. It's actually manages how many requests you can send. It's like subscription based. You can do
Right.
that as well. On
So let's not go into too many details. Like let's not do a deep dive into API gateway. I think Naveed's question, it's a very good question, right? It's at the model, at the architecture level. Let's suppose we say, okay, we are building a new application. Should we use server-based or should we use serverless? That's the question. So the way I would answer is the general push from the AWS and the community, right, is to go with serverless. The advantage of serverless is that you don't have to manage the infrastructure. And as you saw initially, one of the objectives was of modern application development was that you want to have low operational overhead. So when you don't have servers to manage, your operational overhead significantly gets reduced. And then instead of hiring a DevOps engineer, you can hire an engineer to focus on innovation, right? So this is an example. So that's a general approach. But let's suppose your team decides, hey, we want to use Django because that's what we use. We are experts in Django. But Django doesn't run in the serverless space, right? Django operates in the server-based space. So there, it's a very legitimate decision to make that since we want to use this specific framework, we are going to go with server-based, right? But then you need to be aware of the operational overhead that you're going to have. So it's, you weigh all your options and then you make the right choice, you know, the choice that's right for you. So hope that answered your question, David.
Yeah, to some extent it answers, but what if the scalability or the number of API requests are something like this is a concern. The application is going to be scale up and we are going to add new features, then what will be the choice? Good choice.
Yeah, I mean, scalability, serverless scales provides you the most seamless scalability. You don't even need to manage scalability yourself in the serverless space, right? So on paper, when you look at all the options, all the pros and cons, you go with, by default, you should go with serverless.
If we take an example, like if we take both approaches and we are going to push a new feature in our application. So what happens that if we go with the server, we have to take a downtime because we are deploying things.
No, that's why that is because you don't have modern DevOps best practices incorporated, right?
But if we go with serverless, it will be a separate deployment for that feature. There will be a Lambda function or whatsoever.
Yes.
It's getting a rest of the application is working as it was working previously.
Right.
None of the Lambda function is getting updated or
Yeah.
that is being changed. So this functionality will be separately.
So I'll give you an example. For example, and the concept here is blue-green deployments and canary. This presentation is going to be longer, but it is good. I love the fact that it's interactive, right? The concept here is blue-green deployments and canary deployments, right? Blue-green deployment is that you route 50% of your traffic to the green instance. Green instance is your new instance. Blue instance is your current instance, right? Canary deployment is basically same, but the difference is you only route a specific percent of traffic to the new instance or new version. You could choose 5% or 10%, and slowly you can ramp it up, right? So this approach gives you the flexibility to slowly ramp up the traffic and also roll back, because your current instance of the function or the server, right, it's still there. So if you incorporate this approach in server-based and serverless, you're not going to have any downtime when you make your deployments. But once again, on serverless, it's just easier to implement this. Within AWS in Lambda, you are going to create an alias. That alias is going to point to a specific version of the Lambda function. And then from the alias configuration, we're going to say that this route this percent of the traffic to the new version. So that's all you're going to do within AWS. Okay, anything else, Naveed?
No, thanks. That explains.
Now I'm going to skim through these. Okay. File processing. If you are building a file processing application, you could use S3. You upload files to S3. S3 has events notification. For example, when one event notification is that whenever an object is uploaded to S3, notify me. Now that notification could be a Lambda function, it could be an SNS topic, right? And there are a few other targets which are supported. So in this case, we are invoking a Lambda function, and then Lambda function is processing the file. So that's how you could build a file-based processing application using serverless services within AWS. If you are building a streaming application, once again, serverless streaming application, you can build it by using Kinesis, which is Amazon's stream service. You can load and it's a real-time stream service. You can load the stream into Kinesis and then integrate it with Lambda. That Lambda can be used to process the stream data. Similar architecture for IoT backends, right? The devices, the sensor data can send the sensor data into a Kinesis stream. From there, you can run Lambda and do whatever processing you need to. For mobile backend, it's similar to the web backend, web application that we discussed. You're going to have a REST API through the API gateway, and then you're going to integrate the REST API with Lambda. That's going to run the business logic. And then based on whatever your business logic is, you will process the requests. If you want to build GraphQL applications on AWS, then AppSync is your service. AppSync lets you build GraphQL APIs and GraphQL applications. Another thing which it lets you do is you can consolidate data from multiple sources. You know, it's a common scenario where your front end or your client applications are getting data, some part of the data from one service, another part from another service, right? If using AppSync, you could just have a single API that consolidates data from Amazon DynamoDB, APIs, Lambda, microservices. It supports a bunch of data sources. It supports them natively. And then you can also write custom logic, for example, if you want to get data from a custom HTTP endpoint. The concept there is resolvers. So you have resolvers, and then from resolvers, you can specify what is the source of your data. And then that resolver is used to get the data and send it back to the client. Another thing which you can use AppSync for is if you want to build PubSub APIs, and it's going to use WebSocket connections to implement the PubSub functionality. Any questions so far? So if you have let's suppose a traditional Django-based application, you want to move to the serverless model. The best path for you is to containerize it and use AWS Fargate. So Fargate is serverless compute for containers. So you're going to have, it's going to be serverless, and it's going to be your existing application. Your Django application would be serverless. I mean, obviously you could do a migration to the API gateway and Lambda thing, but it's just going to be a lot of effort with no business benefit, right? You want to move existing application to serverless and get benefit from the less operational overhead, move to Fargate. Use ECS and use Fargate.
Yeah.
I really wanted to talk about Amplify because I think it's an amazing tool, and with time it has evolved and matured, and it's going to continue doing that, right? Amplify lets you build full stack applications, web and mobile, end-to-end. It provides you the tooling, the libraries, the modules, the whole thing, from end to end, what you need. And it just makes it easy and faster for you to build full stack web applications, right? Within AWS, if you need, as an example, within AWS, if you need authentication, you're going to use Cognito. You're going to go and either create a Cognito user pool from the console or use IAC. But if you are using Amplify, all you need to do is use the Amplify CLI and say Amplify add authentication. That's all you need to do. And under the hood, it is going to create a Cognito pool for you, but you don't have to deal with this complexity. You just ran one command, it's going to ask you some questions, and then it's going to create the resources for you. Right? Same goes for database. It's right now, I think the last time I checked, it creates DynamoDB databases for you. And if you want to add an API, you're just going to say Amplify CLI add API. It's going to ask you, is it going to be REST based or it's going to be GraphQL? If you select REST, it's going to create an API gateway. And if you select GraphQL, it's going to create an AppSync instance for you. So that is why I think Amplify, the next new application that you work on, do consider using Amplify. Now, this is just for the backend part, right? For the front end part, first thing is it provides you hosting for your front end applications. It will provide you CI/CD pipelines out of the box and a few other things with like routing, rule-based routing for your front end application, and a few other things that just makes it easy for you to host and deploy front end application. Yes, it provides you CloudFront out of the box. So when you deploy an application on a front end application on Amplify, it also provisions the CloudFront, associates a CloudFront instance with your front end. So can anyone explain what CloudFront is and how it helps?
You basically have several edge locations where your application is cached. So that results in lower latency.
Right. So let's talk about Amplify. Let's talk further about Amplify. Right. This is an example of like a sample architecture of what you could have with Amplify. So as I mentioned on the UI layer, I mentioned about hosting, but Amplify also provides you UI components like forms that you could just take and reuse. Also for displaying data to users, there are Amplify libraries. I mentioned about Cognito, right? So once you are able to create a Cognito user pool in the backend, you need to connect your application front end to Cognito, right? Amplify is going to provide you libraries for that. It's gonna make it easier and faster for you to integrate Cognito and integrate all others backend services with your application. So here, if you look at this example, we are using the Amplify abstraction is authentication. Under the hood, it's using Cognito. Then for data, for the data abstraction under the hood, we are using DynamoDB. Storage, it uses S3. So this is one example. Also, you have Amplify Studio now, which actually lets you build a full stack application, the back end, right, and all the components from a studio. It also gives you Figma to code functionality. In front-end development, as you know, big challenge is being pixel perfect. So with Amplify, you feed in the Figma design, it is going to generate code for you. I haven't used it. I don't know how good it is, but hopefully at some point it gets to a point where we can actually rely on it. All right. Okay, we are moving on to containers. Okay, no. So obviously containers are extremely popular, and rightly so, because it provides so many benefits. Okay. For containers, Dockers are the most popular container technology. We have all used Docker. But then you also need something when you talk about deploying containers in production or in other staging environments, you also need something that is going to manage the containers, which is called the container orchestration service. For container orchestration within AWS, you have two main options, actually two options. One is ECS, the other is EKS. ECS is AWS native container orchestration service. EKS is just a managed Kubernetes instance. Okay. So if you are already on AWS, you know AWS, well, right? I don't see any reason to use EKS, because then you should use ECS. Number one, it's cheaper. ECS is free. You only pay for the underlying compute. You don't pay for the cluster. EKS, you pay for the underlying compute. You also pay for the managed Kubernetes cluster. The other thing is that ECS natively integrates with AWS services. For example, if you want to use a load balancer and ALB with your application, within ECS, you're just gonna connect it or integrate it with an ALB. If you compare what you need to do in EKS or Kubernetes, you'll have to create an ingress. Okay, and then under the hood, the ingress is going to create an ALB instance. So you need to know about the ingress abstraction as well as you need to know about ALB. So because Kubernetes is a cloud agnostic technology, right? So there are abstractions that you need to understand, and Kubernetes, that's why it's great, but it's also complex. So similarly, if you want to use volumes in ECS, all you need to do is just create an EFS volume, and ECS is going to integrate with that natively. But within Kubernetes, you have to create a persistent volume. Then you have to create persistent volume claims. And then you also have to create EFS volumes that is going to support your persistent volumes. So you see the multiple layers of abstraction and the complexity, right? So, but there are obviously, EKS, Kubernetes is extremely popular, and rightly so, because it's a great piece of technology. It's the most popular platform within the DevOps and container orchestration space, right? And there are strong reasons to use Kubernetes depending on the use case. For example, if you want to be cloud agnostic, use Kubernetes. If you are working in a company who have not made a decision yet which cloud platform they will go with, I happen to work in a project where we were in this scenario where we didn't know which cloud provider we will choose. So that's why we went with Kubernetes. Similarly, larger companies, they make deployments that are multi-cloud. So the same application would be running on Azure, and the same application is running on AWS, right? And you're load balancing, or you have a DR or whatever your setup is. In that case, also, it definitely makes sense to use Kubernetes, because then you have the same Kubernetes manifest or Kubernetes settings deployed on the two different cloud. And obviously, last but not the least, if you are already on Kubernetes, you're moving to the cloud, there's no need to migrate to ECS. There is no business value in that. Then you use EKS. And obviously, because this is also like a major consideration. If you have a team, which in this case, your team would already know and be experts in Kubernetes, so instead of having to retrain them or hire new people with ECS expertise, you just use your existing team. You just move to EKS, and you already have the skills and expertise within your team for Kubernetes. Any questions on this?
I just wanted to add another like important difference between EKS and ECS. Is that like EKS is basically a lot more open source than ECS, so you also have that going for you if you want like more specific, like individual control over like specifics.
Excellent point. Okay, this is the second last slide, just to let you guys know. Initially, I mentioned about event-driven. I want to touch on it a little bit at a higher level. So as I was saying, event-driven development, event-driven architecture means that you are building loosely coupled applications, right? Within AWS, the service for event-driven development is EventBridge. within EventBridge, there is a concept of event bus. So publishers publish on the event bus, subscribers subscribe to specific events using rules. So that when those specific events happen, they get notified. And the event bus is basically the router, the broker, whatever you call it, that is managing this. It's keeping track, it's ingesting the events and also publishing the events to the interested subscribers. Okay. As an example, let's suppose you are a DevOps engineer for a company and they want to log or they want to analyze all the actions taken by the root account. So anytime an action is taken by the root account, you want to analyze it. And if you find an issue, an anomaly, you want to cut a ticket. Because you are not supposed to be using the root account. Only in exceptional situations you should be using a root account, right? So you are going to create a rule, and in the rule details, you're going to say, okay, I am interested in the CloudTrail events where the user is root. And when this happens, you invoke my Lambda, this specific Lambda function. Then in that Lambda function, you're going to analyze the event, and if it's something which is critical, which needs to be looked at, you are going to cut a ticket in your ticketing system. This is one example. Okay. Then there is also another service within EventBridge, which is EventBridge Scheduler, which is a very commonly used service. If you want to schedule any job on AWS, you use EventBridge Scheduler for that. All right. You basically define a schedule using a cron expression or time window or a fixed rate. There are multiple ways for you to define the expression. Specify a specific date and time. Then you select the target. It supports over 200 AWS services as target. And then you select a few more options, and then the event gets scheduled. Okay. So this is it. Anyone has any questions? Go ahead. Okay. Okay. Well, thank you everyone for joining, and you can turn off the recording.